G'day guys, I've got a basic differentiation or an introductory calculus question today. So if you're just beginning to learn about differentiation and rates of change, or you just need to double check what you know, this is probably a good video I would say for you. So what have we got here? We've got this quadratic a in terms of t, and we have to find an expression for the instantaneous rate of change of a with respect to t. We also have to find the instantaneous rate of change of a with respect to t when t is 0, and t when the instantaneous rate of change of a with respect to t is 3. Okay, so let's go through this quite slowly. What we have here, an expression for the instantaneous rate of change. So when we see this statement in any of our questions, what we have to do is we have to take the derivative. So this piece here means we have to go a dash of t. So we have to take the derivative of the function a with respect to t. So let's go about doing that. So for part A, we have a. We have to find a dash of t. Now, to find a dash, what we're going to do is we first of all multiply the power by the coefficient. So we have 2 times 2. Then that gives us 4. Then we lower the power by 1. So it'll be t. Rather than 2, it's going to be t to the 1. So t to the 1 is simply t. We then do the same here. Now we can say this one here is just t to the 1. So 1 times negative 5 is still minus 5. And 1 take 1, or lowered by 1, is 0. Anything to the power of 0 is 1, so we can leave that off. And as a result, this is our derivative. It's that simple. Now, you'll notice if you do quite a few of these functions and you do derivatives of straight polynomials like this, if you do the derivative of a quadratic, you'll get a linear function. If you do a derivative of a cubic, you get a quadratic. Quartic, you'll get a cubic, and it goes up like that. So your function that you get as a derivative, or a function that expresses the instantaneous rate of change of the dependent variable with respect to the independent variable, is always 1 less power than the function that you have. That rule sort of goes out the window when you start to talk about reciprocals and exponential functions, but for polynomials it works pretty well as a check. So that's A. Now let's get on to B. The instantaneous rate of change of a with respect to t when t is 0. So we have to get a dash of 0. So all we do there is we substitute in 0, t equals 0, for t in our instantaneous rate of function. Instantaneous rate of change function, sorry. So we have 4, bracket 0, take 5, and 4 times 0, obviously 0. Take 5, this is just equal to negative 5. So it's negatively sloped when t is equal to 0. Alright, and C, yep, that's all we're doing. C, t when the instantaneous rate of change of a with respect to t is 3. So we have a dash with respect to t has to equal 3. So 4t take 5 must equal 3. We can rearrange this and we're going to have t is equal to 3 plus 5 on 4. 8 on 4 is 2. So what are we doing when we are finding the instantaneous rate of change? Well, if we have a function, let's just say we've got our Cartesian plane, and we have a function, whether it be a quadratic, a cubic, I don't really care. But we have a function that looks like this. Now, instantaneous rate of change simply is the gradient of the curve at any one point. So here we've got a gradient that's kind of positive. It goes, look at that. So that's my really bad example of a tangent line. So it touches the curve only once, but you can see at this coordinate point here, this function has a positive gradient. If we were to take the derivative over here, you'll notice that if I just draw a tangent through there, it's got a negative gradient at this particular coordinate point. So this is what we're sort of looking for here. We know that the gradient at 0 is -5, and to get the gradient equal to +2, we need to have, to get the gradient equal to +3, we need to sub in t equals 2. So I hope this video helped, guys. It's just a quick run through of basic differentiation of quite a low power polynomial function. But these questions here are ones that come up a lot in your exams, just to make sure that you understand it. This is questions that you have to nail on the head if you want to do well in any kind of calculus course. But I hope this introductory video helped, and as always, guys, I'll see you next time. Enjoy your study and your maths.